So that's a bar chart. That's a bus, that's a train, that's a bike, that's walking, I don't know, to school, to school. There is no link between bus, train, bike, walk, okay? So where bus stops, train doesn't begin, and where train stops, bike doesn't begin. These are 4 discrete individual modes of transportation for getting to school. So I didn't bother with this year 7 stuff. We're in year 9 now. So what we're doing now is not a bar chart, and I don't think you've seen it in year 8 either. It's called a histogram. So please note, there is no continuous link between where bus stops and train begins. These are 4 different things, therefore they never, ever, ever touch. Well, today we're in year 9 and we're doing histograms. You use histograms, and don't call it that, it's a histogram, when playing with continuous data. Look at this. These are the heights of 30 children, so it says. Now, let me ask you about child 140 centimetres. This height category, or this class as it's called, each of these are called classes, begins at 130 centimetres and stops just below 140. But where 140 stops there and 140 begins there in the second category or class, there is no natural break between numbers. Numbers don't just go up in ones. They don't go up in 0.1s, they don't go up in 0.0001s. There is an infinite number of zeros before I hit the 1 at the end. Yeah, it's a continuous measure, okay? If any of you were to be measured up against a wall with a ruler and you came to be 182 centimetres, I promise you, you will not be exactly 182 centimetres. Not that we could measure anyway. With any instrument in the whole universe, you would never get down to the finest nth decimal place to say I'm definitely this. So these measurements are continuous. They call it continuous data, data that is measured rather than counted, okay? So the representation on a bar chart, or better known as a histogram, is such that the bars touch. Look at this, it's a bit difficult to see because it's in blue. So where 130 begins, well, that's easy, that's where it begins. There's no one of less height than 130 in this class of 30 children. But where the 140 stops in this category, the 140 begins in the second category or class. Hence, the bars must touch. Look at this, from 130 up to 180 with no gaps in between them. Unlike the cheap budget version, which is a bar chart. We're not doing that. This is continuous data, and therefore you have a normal scale. You have a y-axis from 0 to 12, because 11 kids are within this height category or within this height class. So 0 to 12 is good. There's no point starting at 0, 10, 20, 30, because no one's that tall. These are children. These are not, embryos or fetuses. Yeah, these are kids. And the littlest is 130 centimetres, potentially. Or at least we can say that 4 of these students are within this height category or within this height class. So, okay, it still goes from 130 to 180, a regular scale. If you change the width of these scales and make it random, the width of these bars and make it random, you were wrong. They're clearly going up in tens, and therefore there must be an exact width. And of course the frequency you know all about, that's just the number. I'm not going to read that. You need to study this, Ibrahim. You need to study this, everyone, because I will return all your bar charts, because it's not a bar chart. Now look at question number 1. The grouped frequency table, which is a fantastic description of what it is, on the right, that one, shows how many seconds, S, it took 22 children to complete a puzzle, and it wants you to draw a frequency bar chart. Scratch that out, it's a histogram. So Clearly the frequency on the y-axis will go from 0 to 8 or 0 to 10 if you want to make it look nice and even. And you can start from 0 and go up to 50, because even though nobody did it between 0 and 10 seconds, it's not such a far distance from the origin so as to be like a waste of space. Do you understand? Whereas here, if we went 0 to 10, 10 to 20, 30 to 40, there'll be all this space with all the other bars bunched up on the right-hand side, you know, of the graph paper. That's just weird. So that's terrible. So start in a sensible place. I can see that both question 1 and question 2, they do start from very sensible places. This you can go from 0 to 10 to 20 to 30 to 40, and look how they've labelled it. See? Very clear. So you need to do that bar chart. Sorry, I'm going crazy now. This histogram for this data. You don't need to copy out the table. Then you do question 2. You don't need to copy out the table. And for question 3, you don't need to copy out the histogram. Look, they got it right. These are journeys from 0 to 1, 1 to 2, 3 to 4, 4 to 5. There's nothing between the 4 on the 3 to 4 and the 4 on the 4 to 5. There's absolutely no gap whatsoever. And it's asking about pupils getting to school and how far they live from school, their journey to school. How many pupils had a journey of 5 kilometres or less? Well, it's that bar, that bar, that bar, that bar, that bar. Just add up the numbers. How many pupils had a journey of 6 kilometres or more? That one and that one. I can see that's 1 plus 1. 2 students had a long journey to school. What is the modal class of this data? What does that mean? No, that's the median. The mode is the most common. Yeah? Most common. So the most common bar, please don't write down 3-4. That's wrong. It's 3 less than or equal to length, which is less than 4. Not 3-4, it's not that. You've got to present it the proper GCSE way, because actually 3-4 means I could be 3 kilometres away from school and I could be 4 kilometres away from school. That's not true, because if you're in the 3 to 4 category, then actually you're just a billionth of a millimetre under 4, because it does say under 4. So this should be 3 less than or equal to, I don't know, D for distance, L for length, which is less than 4, but not equal to 4. Because if you're equal to 4, you're in the next group, the 4 to 5s. And that's it. So I need you to practice, Ibrahim, doing this again. So it looks like that, and so that it looks nothing like that. All right? This is all year 7 work. I'm not interested in that. All right, so as a learning thing, many of you, or some of you, like to do the work early and send me it before I've had a chance to teach the lesson. Now, me knowing this is new to you, you needed to hold back on that. And thank you for trying it, but you got to redo it. Okay, so I think I'm done with that. So just to reiterate, do a histogram for this data, do a histogram for that data. Don't copy out the table. Don't copy out that histogram. Just answer the questions. That's it, I think.